We're solving problem 8 from the 2018 F equals MA exam 8. A disk of radius r rolls uniformly without slipping around the inside of a fixed hoop of radius r. If the period of the disk's motion around the hoop is t, what is the instantaneous speed of the point on the disk opposite to the point of contact? Here we have a rough sketch where capital R is the big radius and the lowercase r is the radius of the smaller disk inside. Since the disk rolls without slipping, v sub r, the velocity at the radius is 2 times the velocity at the center of the mass. So we know that now we have this. We want to see how much this travels, the small disk travels in the big radius in some period of time. So we say that the velocity of the center of mass would be 2 pi capital R minus R over t, because we know it travels this much in any time period t. Since v sub r, the velocity at the radius, is 2 times this, we just simply multiply it by 2. So v sub r, that's not an r, is equal to 4 pi r minus r over t. And that is our answer for this problem.